Next talk, Nadia Heninger is going to tell us a brief chat about approximate GCDs.
So I'm Nadia Heninger, and I thought that we would sit down and talk a little bit about the approximate GCD problem. This is joint work with Cohn. So just so that we all know what the approximate GCD problem is, say you want to solve this problem, you get a bunch of near multiples of some integer p. So you multiply p by some number and you add some small error. And the problem is, given some number of these, you want to find p. And the original motivation for this problem was factoring an RSA modulus given partial information about the bits of some of the factors. So since then, much more recently, it's been used as a hardness assumption underlying two fully homomorphic crypto systems, one from Eurocrypt last year and one in this crypto. The big assumption that they're making is that this approximate GCD problem is as hard for m samples as for 2 samples, and that the best way to break it is to brute force over the noise for the approximate GCDs. So when I saw this, I was kind of like, huh? My work with Henry, we give a lattice-based algorithm to solve approximate GCDs given many samples. And this is the natural multivariate extension of the Coppersmith-Halgrave-Graham technique, where you essentially construct a huge lattice and find some short vectors in it and solve some equations. And fairly naturally, as the number of samples increases, the amount of error that you can tolerate increases as well, up to p. And as a bonus, the polynomial analog of this algorithm is actually a list decoding algorithm for a whole class of error correcting codes. It turns out that the coding theorists knew how to solve this before the cryptographers did. So I applied this to these two papers. So the first paper is the one that I guess will appear tomorrow. So assuming sort of an average case LL approximation of 1.04 to the dimension, I can give you concrete lattice dimensions for the size of lattice that we would have to solve for each of the key setting sizes for the paper that will appear tomorrow. You can decide whether you think these are reasonable to solve or not. And for a more asymptotic analysis, since the paper in Eurocrypt only gave sort of asymptotic settings, what I can say is that while we still can't actually provably break their settings in polynomial time, any polynomial setting for their keys, any polynomial size of keys implies a hardness of lattice basis reduction that is just slightly sub-exponential. So their suggested key size can be broken given a lattice approximation of 2 to the dimension to the 2/3. However, if you assume worst case enumeration time, then you're still stuck with the same running time as just brute forcing the error size. So this is on ePrint, and I invite you to read it. And now Ian Goldberg has a small poem.
So now that I have tenure, I'm branching out into poetry. So I will summarize Nadia's work in the poetry form known as a double dactyl, or sometimes a higgledy-piggledy. Higgledy-piggledy, Nadia Heninger works on some problems about GCDs, full homomorphisms over the integers, multi-dimensional lattices ease. Thank you.